Hello, my name is Tom Worth. I'm presenting a project called Painting2Auction, Art Price Prediction with a Siamese ConvNet and LSTM. Art price prediction is important because it helps both artists and auction houses make better decisions, but the problem is that good prediction information is restricted to whether one has access to a small number of highly trained experts who are good at evaluating paintings. The hope for automation is that we can make this information more accessible for everyone and that we can remove biases introduced by human evaluators who, for example, predict higher prices for works by artists associated with prestigious institutions, and then these paintings with high valuations go and actually do better in the market because buyers see that they're valued higher. So automated prices would make the art market both more open and more equitable. The problem is that existing prediction methods with deep learning either get very poor performance if they try to go straight from an image to a price because there's just not that much intrinsic to the visual input to go off of, or they use things like metadata on the artist and NLP on things experts have said about the painting, so they reintroduce the bias that we were trying to get rid of in the first place. My solution is to incorporate recent market data, but to keep the prediction artist agnostic in hopes of getting a better prediction than the naive models without reintroducing the bias. I do this by creating a Siamese CNN to evaluate the similarity between paintings and then compare the painting that I want to predict with recently auctioned paintings and combine these similarity scores with the recently auctioned paintings' prices to try to produce a better prediction for the new painting. So when I created the Siamese CNN, I first evaluated its performance by seeing if it could guess whether two paintings were by the same artist or not, and trying it out on this task with different underlying CNN architectures. You can see the list of architectures that I tried here and their respective performances in this chart and the graph. The one that achieved the best performance was actually the vanilla CNN, and it correctly guessed whether a pair of paintings was or wasn't by the same artist 86% of the time. And you can see a diagram of that architecture here. It's just a basic Siamese CNN with two convolutional layers. So it was this model that I then incorporated into my price prediction models, which were a k-nearest neighbors approach and an LSTM. The baseline that I was comparing these price prediction models against was the naive CNN's mean absolute percentage error of 1,841, which is not much better than random guessing, which gets an MAPE of 2,351. The k-nearest neighbors model got an MAPE of 227 with the hyperparameters that you can see on the screen, which is much better. And here's a visualization of what the Siamese CNN singled out as some nearest neighbors for a couple of given inputs. So as you can see, it is picking up on relevant aspects of the paintings like patterns and color palettes and levels of abstraction. Then moving on to the LSTM, with a very simple single layer many-to-one architecture, taking a sequence of similarities concatenated with prices as input, it ended up getting an MAPE of 100.08 with these hyperparameters. Again, significantly better than the baseline and even better than the nearest neighbors approach. This is its learning graph across 8 epochs and its validation set performance across different sequence lengths and learning rates. This is an example of a well-predicted painting. As you can see, it's about 50% error in this case. So, to sum up, the vanilla Siamese CNN was best at judging painting similarity, and when I plugged that into two price prediction models, it was able to use images and prices of recently sold paintings to produce price predictions for a new painting, which were much better than the naive CNN baseline model. Thank you to Andrew, Kian, and Jonathan, my project TA. I've really learned a whole lot this quarter, and here's my email if you have any questions. Hope you like my project.